Today, visual-inertial odometry systems still fail in high-speed and high dynamic range scenes. In this example, the camera was shaken fast in an office. Because of motion blur of the camera and strong light changes in the scene, no state-of-the-art visual-inertial system is able to track the camera accurately. In this work, we propose the first system that can use together an event camera, a standard camera, and an IMU to perform robust 6 degrees of freedom visual SLAM in high-speed conditions in high dynamic range scenes. Event cameras are novel sensors that measure only motion in the scene. When we keep an event camera steady, only motion in the scene generates events. However, when we start moving an event camera, gradients in the scene become visible. Compared to standard cameras, event cameras have very low latency, they do not suffer from motion blur, and they have a very high dynamic range. For these reasons, they are well suited for visual odometry. Let's see how Ultimate SLAM works. In the first step, the events are grouped in batches and used together with the IMU data to synthesize event frames that are free of motion blur. Then, visual features are detected and tracked both in the event stream and in the stream of standard frames. Finally, the feature tracks from both data sources are fused with the inertial data using nonlinear optimization, yielding new pose estimates. We evaluated our pipeline on multiple sequences and compared it against the state-of-the-art pipeline using frames and IMU in green and one using events and IMU in black. Each of these plots shows the translation error as a function of the travel distance. Our pipeline in blue has consistently lower errors, showing it can successfully fuse events, frames and IMU. On average, using events provided a boost of accuracy of 85% over a frame-based approach only. We also implemented Ultimate SLAM on board a quadcopter equipped with a Davis camera and an onboard computer. In this video, the quadcopter autonomously performs multiple circles. To show the impact of using an event camera, we will soon switch the light off in the room. As you can see, despite this drastic change of lighting and the very low light conditions, our pipeline is still able to provide reliable state estimates, thanks to the high dynamic range of the event camera. When the light is on, the standard camera provides good quality images, which Ultimate SLAM uses for tracking. As soon as the light is off, the standard camera becomes blind, but Ultimate SLAM can still track features in the event stream, which allows to keep a stable state estimate.